Hello, knowledge seekers. Welcome to Remedial Tutorial Academy. In this video, we are going to learn how to convert a complex number in the rectangular or Cartesian form into the polar form. So, giving a complex number, say z equals x plus jy, now let's call this equation 1. And this is the rectangular or the Cartesian representation of the complex number. So, rectangular or the Cartesian representation of the complex number. Now, at this point, we are going to represent this complex number on a graph, and this is made possible by the use of what we call the Argument diagram. This diagram helps us to represent a complex number in the Cartesian plane. So, assuming that this is our Argument diagram, we have the real axis and the imaginary axis. We have O to be the origin, and we have the complex number z, which is equal to x plus jy, represented on the graph. On the imaginary axis, we have y, and on the real axis, we have x. We have r to be the hypotenuse and the angle theta formed between r and x. Now let's focus on this triangle. So from trigonometry, we know that sine theta is equal to opposite over hypotenuse. So opposite to the angle theta, we have y. So that is y over the hypotenuse SR. So we can say that y is equal to r sine theta. We have cos theta also to be adjacent over hypotenuse, so that is x over r. In that case, we have x to be equal to r cos theta. Now, from equation 1, we know that z is equal to x plus jy. Now, we are going to substitute the values of x and then y in here. So this becomes r cos theta plus j r sine theta. At this point, r is common to both terms, so we can factor out r so that inside of the brackets, we have cos theta plus j sine theta. Now, this is called the polar representation of the complex number, and this can be reduced as r cis theta. So basically, this is the shorthand form of the polar representation of a complex number, where r is referred to as the modulus or the magnitude of z, and thus written as mod z, or the absolute value of z. Also, theta is given by tan inverse of the absolute value of the y component divided by the x component. And this angle theta is referred to as the argument or the amplitude of z. Now, this theta is the angle that z makes with the positive x-axis. So theta is the angle z makes with the positive x-axis. Notice that if z, or cis theta, occurs in the first quadrant, then we are going to use this approach to find the value of theta. However, if it appears in the second quadrant, the third quadrant, or the fourth quadrant, then you need to perform further calculations in order to arrive at the final value of theta. So even before we take some examples, notice that the value of r can be found by using this formula. That is the square root of the x component squared plus the y component squared. Determine the modulus and argument of z and express z in the polar form. So for I, we have z to be 2 plus 3j. Now, this is the rectangular representation of the complex number. We need to convert this to the polar form. So in order to do that, first of all, we need to draw the Argument diagram. We need to represent this complex number in the Argument diagram. So we draw our diagram. We have the real axis. We have the imaginary axis. On the real axis, we have the x component to be 2, and on the imaginary axis, we have 3. So we have z equals 2 plus 3j. This is the angle theta, and then we have r, that is the modulus. And at this point, you realize that the complex number is formed in the first quadrant, or the complex number appears in the first quadrant. Now let's move on to find the value of r and theta. So we know that r is equal to the square root of x squared plus y squared. We have x to be 2, so that is 2 squared, plus we have y to be 3, so 3 squared. So we have the square root of 4 plus 9, and that is equal to the square root of 13. So we have r to be the square root of 13 units. Now let's find the value of theta. So theta is given as tan inverse of the absolute value of y divided by x. So this becomes tan inverse of, we have y to be 3 and then x to be 2. So tan inverse of 3 over 2 gives 56.31 degrees. So this is the value of the argument. So now let's represent z in the polar form. So we have z equals r into brackets cos theta plus j sine theta. So this becomes the square root of 13 times, in a bracket, we have cos 56.31 degrees plus j sine 56.31 degrees. The square root of 13, polar, 56.31 degrees. So this is the polar representation of the complex number 2 plus j3. Now let's move on to I. So for I, we are going to represent the complex number that is -3 minus 4j in the polar form. So we have this to be our Argand diagram. Imaginary axis, we have the real axis. We have our x component to be -3, so this is -3. Y component, -4, so this is -4. So this is the complex number z equals -3 minus 4j, and this happens to be formed in the third quadrant. We have this to be r, and let the angle between r and the negative x-axis be alpha, that is, the angle r makes with the positive x-axis. So this is the angle theta. So after finding angle alpha, we are going to add 180 to it in order to get the value for angle theta. So from this point to this point is 180 degrees. And notice that we always move in the anti-clockwise direction to meet r. So now let's find the value of r and then alpha. So for r, that is equal to the square root of x squared plus y squared. We have x to be -3, so -3 squared, plus y is -4, so -4 squared. This is equal to the square root of -3 squared is 9. -4 squared is 16, so that is the square root of 25, and this is equal to 5 units. Therefore, we have r, which is the modulus, to be 5 units. Now let's find the value of alpha. So alpha is given by tan inverse of the absolute value of y divided by the absolute value of x. This is equal to tan inverse. We have the absolute value of y to be 4, absolute value of x to be 3. So tan inverse of 4 over 3 is 53 degrees. So this is the value of alpha, this angle. Now, in order to find the value of theta, we are going to add 180 degrees to 53.13. That is, we are going to move from the positive x-axis in the anti-clockwise direction to meet r. So this is the angle theta. So theta is equal to 180 degrees plus 53 degrees, and that is equal to 233.13 degrees. So this is the value of theta. Therefore, we have the polar representation of this complex number to be 5 into brackets cosine 233.13 degrees plus j sine 233.13 degrees, which can simply be expressed as 5 polar 233 degrees. Thank you so much for watching. I hope you enjoyed. Please comment down below what other topics you'd like for me to review. I upload new videos every day. Don't forget to subscribe and share for your friends and classmates. See you next time.